So today what I'd like to talk about is our barred owl removal experiment. I want to talk not as much about the science initially, but to talk about why we chose to use this experimental approach to this particular issue, how we're proceeding, and I will give you a summary of both our experimental design and some of the very preliminary results. But before I start that, I'd like to know how many people in the audience, you got to raise your hand high because it's really bright up here. How many people in the audience have heard about the barred owl removal experiment? Please raise your hand real high. Yeah, that's kind of what I expected. I should have said who hasn't heard about it. Yeah, it's definitely got a lot of press over the last few years. I was on a bird walk in the Panhandle of Florida, and one of the leaders and I ended up talking about it, and I did not tell her what I did for work because she knows both species, and we just happened to have a pair of barred owls in their native habitat show up on the walk, which was very nice. Yeah, it's definitely a controversial issue. It involves killing a substantial number of owls, which are migratory birds, which are a raptor, which are charismatic mesofauna, as I call them. So understandably, very controversial. So why did the service even take this on? Why did we tempt that controversy? To set the stage, I want to give you just a little bit of background here on the history of the barred owl. Barred owls are an eastern forest species. Historically, they were limited to the East Coast and to a population down in Mexico, which recently I've heard they're actually considering making its own species. It's that different. On the other hand, the spotted owl is the western equivalent of that. Again, a forest owl that occurs only out here in the west. Based on genetic differences, these two species have been separated for well over 1 million years, probably 2 or 3 million years. So some kind of barrier has kept these closely related species separate through pretty significant changes in both climate and habitat. This is not a time frame in which everything's always the same. Then sometime around 1900, barred owls began to expand their range, and they breached that barrier, whatever it was. Now, unfortunately, we don't have any good data or observations from this period and through this area to allow us to say exactly why they began to expand at this time. Though almost all of the theories that have been advanced to date, all but one that I'm aware of, involve some sort of change to the environment or habitat of either the northern Great Plains or the boreal forest caused by European settlement that then allowed this to happen. Again, no data in which we can prove this. The timing is right, and the changes were significant. Barred owls arrived in the Northwest around the 1960s in British Columbia. The first records in Washington, Western Washington, Oregon, and California were in the early 1970s, and these were scattered individuals, and that remained that way for quite a while. But by the 80s, populations began to actually grow. We didn't have just individual birds popping up. And the main population of barred owls now completely overlaps the range of the northern subspecies of the spotted owl and is making some pretty significant inroads into the California species range. Well, the fact that barred owls are now common on our landscape doesn't mean that they are necessarily a problem, and those two don't necessarily go together. In fact, at the time of listing of the northern spotted owl way back in 1990, the primary threat that was identified to the spotted owl was the historic and ongoing loss of habitat. At about the late 1980s, we had actually gotten our first indication that there might be some issues in the very northern part of the range up in Washington with barred owls, locally at least, displacing some spotted owls. So they were identified in the recovery plan as a potential threat. We just didn't have any idea of the level of threat. Didn't know what was coming. Now, because we had to have some very long-term spotted owl population monitoring, the federal agencies have been able to actually identify and track the decline in spotted owl populations, somewhat unique for a lot of us in the work we do. So we actually have 30 years or more of data in some places consistently collected to allow us to look at populations. And in fact, some of the incidental data that was collected actually allows us to look at potential causes for the declines that we were seeing. Now initially, after the listing of the spotted owl and the Northwest Forest Plan about 4 years later, there was a significant drop in the amount of habitat that was being harvested and removed. And it appeared at first the spotted owl populations were actually responding to this. There was some indication that while they were still declining, the rate of that decline was slowing, or it was lessening. That's until the other shoe dropped. So sometime in the mid-2000s, or actually more recently than that, probably about 2010, we began to notice the spotted owl population trends again were beginning to worsen. It started in the northern part of the range, but has spread all the way south throughout the range of the northern spotted owl now. Now, researchers were able to detect and to count the actual number of spotted owls responding to the surveys they were doing every year, and to show that there was a decline. This is pretty basic stuff. This isn't even stats. This is just mapping, which I like. I can do that, or graphing, I should say. And so we look at, for example, the Cle Elum study area. This is our most northern study area of the places that we're tracking spotted owl populations. And we see that the number of spotted owls they detected on these standardized surveys dropped by 80% in the 20 years up to 2012. If we go to the Oregon Coast Range, things were kind of hanging on for a while, but over the last 15 years, we've lost 70% of the population, again, up to 2012. And in the southern part of the range in Oregon, we've turned it along in about 10 years of that time, but in the 10 years up to 2012, we'd lost 45% of those sites. In other words, site occupancy had dropped by 45%. Now, that doesn't tell you why they declined, it just says you've got to decline. So when researchers then graphed some of that incidental information I talked about, they were able to look at the number of the spotted owl sites they were surveying where they had a spotted owl respond, that's occupancy, and the number of those same spotted owl sites that they were surveying where a barred owl responded to the spotted owl surveys. And we see graphs like this, and this is typical throughout the range. The only difference is in the northern populations, that crossing occurs earlier in time, and the southern populations, that cross occurs later in time. So we see an increase in barred owls, a decrease in spotted owls. Well, it's a correlation. It's actually a really good correlation, but it's not cause and effect. And that's the first thing a good scientist knows is just because two things are doing something that look correlated doesn't mean they are. So people continue to look at this issue, and in fact, over time, the studies up in northern Washington that showed some displacement, actually tracking individual birds. We had some other work like that. We had people following in. Pretty much by 2004, it became obvious that barred owls were causing a problem for spotted owls. In fact, we documented this in our 5-year review, indicating that they were a primary concern, and more so, by the time the 2008 and 2011 recovery plans were written, the evidence was pretty damning. And they actually came to the conclusion that barred owls represented one of the two primary threats to the survival, I'm not talking recovery, to the survival of the northern spotted owl. The recovery plans, both 2008 and 2011, identified the need to manage barred owl populations to protect the spotted owl. But indicating that you need to manage something doesn't tell you necessarily how to do it. So in addition, we went out and we asked scientists and managers, we convened panels, there were workshops that were conducted, papers were written, and in the end, pretty much almost all of these people involved came to the conclusion that removal of barred owl was the most likely successful tool for managing the population. And in fact, in most cases, people came to the conclusion it was probably the only tool we had in our current toolbox that had a chance of being successful. But removal of, at this scale and with this kind of a species, with a predator and an owl, a nighttime species for the most part, was pretty untested. And any of you who have ever worked in removal programs know they're pretty expensive. And I don't mean just in terms of dollars, which they are, but also in the fact that we are going to be killing a lot of birds. And we don't want to do that if it's not doing us any good. It's not something on any of our wish lists, if you will. So we also had some pretty strong opposition. Well, I should put up. So pretty strong opposition within and outside the service to moving into an immediate large-scale removal kind of a management program. We chose instead to take an experimental approach, and that's actually codified in the recovery plans, Recovery Action 29. We wanted to start out by determining if, in fact, removing barred owls was going to work to help spotted owls. Rather than go apply this across a large landscape, let's take a good, solid study and prove up on whether this works or not. In addition, it allows us to test things like the efficiency, the methodology, and to estimate the costs much better. We did a lot of outreach and education in the early 5 years of working on getting to where we are, actually about 7 years now, to getting to where we are today. And by doing that, and with all the information that was continuing to come in, we actually gained some grudging support. I say grudging because some of it was pretty grudging, but support for experimental approach to determine if we were going to be able to use this tool or if it was going to even work. So here's what we're currently implementing. We've decided to do a study with 4 study areas distributed north to south throughout the range of the northern spotted owl. This allows us to test whether areas with a longer invasion history in the north can actually respond as well as areas in the south with a shorter history. We're using portions of ongoing demography, spotted owl demography studies, so we can collect the best data on population effects. We're using a combination of lethal and non-lethal removal, but we've been very upfront that the vast majority, if not almost all of the removal, will be lethal. And we estimate it'll take us about 4 years to reach a statistically significant level of information based on some other studies. We're using a Bakke design, so you know what that means, but basically all of our study areas are being divided into 2 pieces. We survey barred and spotted owls throughout the entire study area. We then remove barred owls from the treatment area only and continue to then leave the barred owls on the control area and continue to survey both populations. That allows us to compare the population trends of spotted owls on the areas that we have removed the barred owls and where we have not. We finished our documentation, i.e. a 500-page EIS and other things, and signed the decision in September of 2013. We were able to immediately initiate the study on the Hoopa study area because the tribe had been surveying for both species for several years, so they had the necessary pre-treatment data. In the first year of removal, in 2013-14, we do our removal in the non-breeding season, so the fall and winter. They removed 71 barred owls the first year, 54 the second year, and 45 this last year. And we'll probably be completing some initial analysis of the data at the end of this year's spotted owl surveys. Now, for several reasons I won't go into, we couldn't start on the other study areas quite as quickly, but we did contract with Drs. David Ween and Katie Duggar of USGS, and in fact, the information I'm going to give you for the rest of this talk, the actual results, are from their work and the work of Mark Higley on the Hoopa Reservation. The surveys began at the other 3 study areas last spring of 2013. We began removals on the Cle Elum, the northern site, and the Oregon Coast Ranges in 2015 in September, and we'll be starting the Klamath study area in 2016. Now, let me give you some preliminary results. Yeah, I know this is a little small, but all you have to see is the color on this. So this is the Cle Elum study area, our northernmost study area. The polygons represent historical spotted owl sites. The pink sites are our treatment portion of the study area. The blue sites are the control portion. Those 7 red dots up there are the 7 spotted owl pairs that were located in 2015. Only 3 of those reproduced. There should be 100. Now, the barred owl results. The red dots, spotted owls. The blue dots, barred owls. There's a lot more. The surveys were done using 500-hectare hexagons covering the whole area. There are 223 of them in our treatment and control areas on this study. They found 141 territorial pairs of barred owls. There were some singles too. That's about 1.3 pair of barred owls per spotted owl territory. Although you note there are several spotted owl territories on here that they did not find barred owls in the first year. We began removals in September. As of the end of 2015, so the first 4 months of the removal period, they had removed 106 barred owls in Cle Elum. That's when the snows started to fall. Thanks to snowmobiles, they've been able to continue some, and we've actually got a few more. They've gotten 125 birds at the end of the season this year. So that's a pretty high proportion of the barred owls that we had in the treatment area. Okay, the Oregon Coast Range study area, a little bit bigger study area. There are 14 pairs of spotted owls that were found on this area. There should be over 100 in this last 2015 spotted owl surveys. There are 277 of those hexagons. 88% of those, they found at least 1 barred owl on. And they actually found 277 pairs. That's almost 2 pairs of barred owl per spotted owl on the average. Yeah, there's a few sites up there that did not have barred owls in them, but very few. And they were able to remove 158 of the barred owls on the treatment area by the end of 2015. You notice there's kind of a hole of removal in the middle. That was an issue with access. We resolved that issue, and by the end of this year, they've removed over 240, including many from within that area. All right, so it's too early at this point to detect a change in population. We just finished the first year removal on most of these sites. But we are fairly happy with the number of barred owls they were able to remove. We learned a lot about technique in the first year of the Hoopa study, and we've applied that in these other studies. So we're now beginning the first year of post-removal surveys on our 2 study areas. We hope to see early results in a couple of years and in terms of trend, but what we're hoping to see this year is perhaps a little bit of change in occupancy. We did do a lot of early work with outreach, and that reduced the controversy, didn't eliminate it. We did get a lawsuit. We've won 2 rounds in district court, and we're now, the plaintiffs decided to appeal, and we're in the Ninth Circuit Court right now, and that's the process we're in. However, they never asked for an injunction, so we've been able to proceed with the study. And finally, funding remains the limiting factor. Removal is expensive. Removal studies are even more expensive. When we're running at all 4 study areas at the same time, it's $1 million a year project. We've funded over half of it so far. We're good out until the 2017 year, and we're continuing to look for funding. And with that, I'm going to hopefully have a few moments for questions. So the question was, what do I know about the population trends or the population of barred owls in their native habitat back east, and what do we know about changes in population trend that might have projections relative to climate change? We know that in general, barred owls in the east are in good populations. They're not considered to be endangered in any state except New Jersey, and the only reason they're considered to be a problem there is they don't have habitat left. If you don't have habitat, you don't have the bird. We actually offered to send ours back. Seriously, I mean, you have to go, when you're dealing with public controversial stuff, you have to take every opportunity. Thank goodness all the states said no thank you. And the primary reason was they have as many barred owls as they have habitat for. They're actually doing quite well. And in fact, in a couple areas, they are causing problems for their own endangered wildlife because they're pretty voracious predators. They're good at it, which is great. I have not seen any projections relative to climate change. They're pretty adaptable birds. They're generalist predators. They're not picky, believe me, at all. They'll eat. Mark Higley down in the Hoopa has video or pictures of birds pulling worms out of his yard, barred owls. So they'll eat pretty much anything. So I think of all the species I've ever dealt with, these guys probably have the least potential for impacts from the changes of climate change because they can react by changing their diet, changing their habitat. They're pretty versatile. The comment and question is this going to be on, if we were to say, prove that this is successful and move forward and do some sort of management, it seems like this is going to be a forever ongoing kind of management. And the answer to that is possibly. And I get asked this question a lot, and the answer the way I usually gets asked is, why are we bothering to do this? Because we'll have to do it forever. We do a lot of wildlife management that we, at least at this moment, think we're going to have to do forever. Pig control, I mean, there's a lot of stuff out there, even with our native species that are doing well, that is forever management. But I look at it this way. If we don't do anything, I honestly believe now, and this is something I've come to over the last 5 years, that we will not have northern spotted owls in my lifetime, certainly in my nephew's lifetime. They're going to be gone. So if we do nothing, the answer is we won't have any. If we do something, and we're not going to wipe out barred owls in the West, we don't want to, and we're not going to be able to if we did. So if we do something, and it may be that we do it in a refugia situation or something, and we keep spotted owls around, we keep our options for the future when we may have other tools. The advances that we have in science and genetics and things like that may give us a tool 30 years from now that we never even imagine now. So we sort of have the choice of saying we don't want to do it, it's really hard, and oh, by the way, it's going to have to happen forever. And yes, we may have to manage forever. One of the things we're hoping to learn, it's not part of what we have funded on this study, but we're hoping that somebody will pick it up, is to continue to watch these areas intensely after we finish removal, to see how fast barred owls really come back in. Because interestingly, up in Canada, where they're just doing a removal program, once they manage to get the owls out of their area, now they have, how many of you are familiar with the North Cascades? You know, I have that kind of what I call fjord habitat. I mean, it runs up the valleys, big mountains between it. That's the kind of habitat they're mostly working in. But once they clean out those valleys, they don't get barred owls back in very easily. So we don't really know how quickly they're going to respond. There are a bunch of theories out there about social facilitation that make us think that may not be the case. But we won't know until we try. And that's another reason to run the experiment. It's cheaper. We can find out the answer. And then if the experiment works, the next question is, are we going to apply this elsewhere? How are we going to do it? How much do we want to invest? And that's when the really tough questions start.